I will take you through safety in automation system on behalf of CII Bangalore. These are the contents of this topic, which I will be taking mainly. Safety and automation relationship, how they are related to each other. Then we will talk about how to implement safety on a system, on a machine, in a process. Then I will also discuss overview of the new standard which talks about the control system of safety. And this new standard is to do with the safety control system. Then I will be just touching upon on risk assessment and safety levels. What are the safety levels as per the new standards? And then I will also be talking about the definition and meaning of safety levels. Then I'll be talking about some safe practices as per IEC standards while implementing safety. And then I'll be taking a session on application-based safety solutions. This will be mainly about some products, some solutions which we generally neglect in our day-to-day work and whenever we want to implement safety on a system. Then we will talk about a typical product called safety relays, which is very, very important in a safety control system to improve both automation as well as safety in the system. And then I'll be taking fail-safe circuit design. So you'll be comfortable with how to design safety circuit, whether it is a machine, process, or any other system. And then very briefly, very quickly, I will take you through a case study, which is about a matchbox company where they made an accident, and then we try to analyze why this accident occurred. Okay. So we start with our relationship between safety and automation. Let's go back to our definitions, which I have taken from, say, Wikipedia regarding automation. We all know what is automation. It is the use of machines, control system, and information technologies to optimize productivity. Okay, and automation greatly decreases the need for human sensory and mental requirements while increasing load, capacity, speed, and repeatability of the system. So this means that automation can work on its own and with less requirement from human interference. Okay. So we can say automation in a system reduces dependency on human beings to carry out a muscular, repetitive, fast work. Okay. Now let's see what is the meaning of safety. So safety is freedom from unacceptable risks of physical injury or of damage to the health of people, either directly or indirectly as a result of damage to property or the environment. And this, in a nutshell, means the person is safe when he is not exposed to any hazardous motions, any hazardous areas, or any hazardous machines, part of the machine or the process. So to make a relationship between these two, we can say if we have more automation in a system or on a machine or on a process, we presume we have better safety. And this is somewhat everyone would agree that we can make a system or machine automated, and then we have a better safety. Okay. So the relationship is very simple. More automation means better safety. But is it true all the time? Because today the automation systems have become very, very complex. The machine, the process has become very complex. And it's not only the auto mode, but there are many other modes of a process or a machine which we have to consider while assessing whether only automation can make that process or machine safe. So the various modes of operations, like say if we say auto mode we all know it is automated mode where less of human interference is required. But what about setup mode? When we set up our machine for the first batch or the first product, okay, or the process, what about that particular mode of the machine? Because under this mode, as well as under maintenance mode, where we have to do maintenance on the machine or the process, we have to interact with the machine while it is running, while the hazardous motions are already in function. So what about safety under these two modes? And what about safety under trial runs, where we observe how the machine behaves with a new product or a new batch or some new speeds which we have to achieve on the machine or the process. Also during installation, erection, commissioning, we have to interact with the machine when it is in running condition. And to tell you the truth, even during dismantling, there have been many accidents. So in today's scenario, where we have more automated system available in the market in terms of machines, in terms of processes, the rate of accidents have definitely decreased on auto mode of the process. But then now the accidents are happening in setup mode, in maintenance mode, during trial runs, during installations, during dismantling, because we generally do not take care of safety under these conditions. And we must never forget that accidents happen only once in a lifetime. It doesn't happen, it might not happen every day, every year, every 10 years, every 20 years. When I take up a case study during end of this session, we will understand that the accident happened in 32 years in that company. So accidents happen once in lifetime. So we have to avoid possibility of this accidents during all the modes of operation of the system, not only during automation mode or auto mode of the system. So there is a very good standard on, you can say, functional safety. This talks about both machine as well as process. This is sometimes also called as godfather of functional safety. And as per this IEC 61508, the godfather of functional safety. Functional safety is something which is related to safety in industry, safety arising or out of functions in the industry. So the challenge of functional safety these days is to design a system in such a way as to prevent dangerous failures. Please, I wanted to repeat, this is prevent dangerous failures or to control them when they arise. Because the chances of accidents are very, very high when we have a dangerous failure. A failure which is in a normal condition may not be that probable to happen an accident, but then a dangerous failure, we are 100% sure the accident would happen. And these dangerous failures can occur from many factors. And one of those factors is incorrect specifications of the system, hardware or software. It can also occur by omissions in the safety requirements specifications, like failure to develop all safety functions during different modes, as I discussed in the last slide. You have taken care of safety requirements only in automated mode. You have not taken care for maintenance mode. Okay. Then random hardware failure mechanisms, also systematic hardware failure mechanisms. Then also because of software errors, which may occur because of many equipments now are based on softwares, like a PLC or a drive. They are based on softwares. So there may be a software error which may lead to an dangerous failure. Then we can also have failures because of common cause which are more related to human errors. Then we also have dangerous failures occurring because of environmental influences. Environmental influences like electromagnetic, temperature, or mechanical phenomena. Electromagnetic, it can be because of electromagnetic interference, like if you do a welding of the machine or welding of a part of a machine, and because of this welding electromagnetic strength, there are some other activities which can be influenced, and the machine can run or machine can behave in a manner which can lead to accidents. Okay, and also because of supply system voltage disturbances. So these are the factors which can lead to dangerous failures. Okay. So just to touch upon the failures, we have mainly three types of failures. One is systematic failure, which is inconsistent specifications happening in case of power interruption, return of power, occurrence of boundary values in the system. Okay. Then we can have random failures, which are defects or failures whose occurrence is unpredictable in absolute sense, but is predictable in probabilistic or a statistical sense. For example, say material fatigues or coincidences of tolerances, okay, or say cross circuits. And then we can also have common cause failures, which is a subset of both systematic as well as random failures. And there was a survey done somewhere in one of the European countries, and it was found that dangerous failures occur, the reasons for them is 44% because of specifications, 20% because of commissioning changes, and 15% each because of operation and maintenance issues, and 15% for design and implementation, and only 6% because of installation and commissioning. So if you see the percentage breakup, we can say approximately around 60% of the dangerous failures are built into the safety related systems before taken into service. Now this is, I have also given the source of this study. You can search on the Google, and you will find this HSE brochure, Out of Control, why control systems go wrong and how to prevent failures. From there you will find all this data available. But this is very, very kind of news to us, or a very new thing, that more than 60% of failures are because of our own wrong specifications or at the design stage only. If we take care of the things at the specification making or design stage, then probably we can reduce a lot of accidents. Okay. Coming to the systematic failure further, systematic failure is unwanted behavior which is repeatable, predictable, and indefensible. It should not occur, but it is extremely hard to prevent, and it arises from human error due to misconceptions or mistakes. And systematic failures also arise from concepts, specifications, building the wrong thing with respect to intent. Means we don't have any intention, but then we don't know about the repercussions. Then design or manufacture, like building the wrong thing, again, including third-party contributions. Use and maintenance, like improper training or procedures, or violating designer's intentions, like designer wants a machine to be operated in a fashion, but the operators operate them in a different fashion. Then also the changes, the challenge of the legacy system when you implement safety or automation on an older system, because of those changes also. systematic failures may occur. Okay. So how do we implement? What is the safety strategy? And this safety strategy holds good for any type of process, any type of safety, any type of machine. And the first step towards implementing safety on a process or on a machine is direct safety measures. These direct safety measures are something which we do at the design stage to make a process fail safe, to make a process without any hazards or risks. And then the second measure should be indirect safety by using different safety devices. Okay, like you use safety devices on a door guard for guard safety, or then you use some other equipments for safety from a machine. And third should be the indicative safety, which is by way of stickers or posters or training or something like that. To give you more example on this, these three patterns, I'll just give you an example here. You see a piston moving vertically, and on the first photograph you can see the finger can get crushed, okay, because of the movement of the piston. So a good design person will try to change the design in a tapered, the piston shape will be tapered so that even if it comes down, it will not hit the finger. On the second photograph on the from the left you can see. This is called direct safety measure. Okay, so you have avoided the risk. There is no risk. The movement is same, but there is no risk. But sometimes what happens, tapering of this kind of a piston may not be possible because of certain other considerations in the design. Then what we do is we prevent the finger from going inside or touching the piston, moving piston. If that is done, then we call it indirect safety, because we have put a barrier, and this barrier is a safety device. Okay, so this is the second step. And if suppose after this also there are some residual risks, there are some dangers, then we can put some stickers, we can put some warning signs for the operators to see that they don't have to perform this task or they have to be careful. Let us come to another example on this. We have two rotating cylinders or spindles, and we have designed them in such a way that they are having some distance between them. Let's take, for example, a rolling machine or a rolling system where paper rolls. Since there is distance between these two rollers, our hand cannot go in and our hand cannot be drawn in. Okay, so the first step, the first photograph, you can see there is no danger, there is no risk at all to the operator. But somehow, if we are not able to implement this kind of a design in a system, then we can put a barrier so that the operator cannot put his hand at all between these two rollers. And the residual risks, even if putting a barrier is not possible, then we can put some kind of a sticker or some kind of a warning sign. Just remember that the sequence has to be direct safety, indirect safety, indicative safety only. The first step has to be direct safety, the second step as indirect safety, and third step as indicative safety. We cannot change the sequence, otherwise we will meet with something else. Okay, so hope this is very clear. This is how we implement safety on a system. Now I will discuss about the control system. How to what does the control system for a safety system looks like? And for this we have a very beautiful standard which was released in 2012. This is called EN ISO 13849-1. This was formulated way back in 2006, but then some transition time was given to all the people, and finally it got mandatory in European countries at least, since January 2012. Okay, this talks about how to design a control system, safety control system, because all safety systems are somehow related to control systems, because the machine has to be stopped in case of an probable accident. So the stopping of the machine can happen only through a control system wiring or a circuit. Just to give you a small background, on the left hand side you can see EN 954-1. So this was the old, you can say, control system safety standard. And on the right hand side you can see the IC 61508, which is the godfather of functional safety. So the new standard which has come, that is 13849-1. It is a amalgamation of these two standards. Okay, so what the standard making organizations have done, they have taken good things from the older standard, that is EN 954-1, and also the good things from IC 61508. Okay, so the new standard, we can say, is more or less quite capable to address the issues today. And you can say the godfather still remains same as IC 61508, which is called Functional Safety of Electrical, Electronic, Programmable, Electronic Safety Related Systems. In short term, it is called EEPES. Okay. Now this has got two offshoots. One is for the machine builders, and the second one is for the process industry. So for the process industry, it is 61511, and for the machine builders, it is 62061 or 061. Okay. So because machines and process have to be dealt separately. In machines, the risks involved are limited, but in the process, the risks involved are manifold. To give you an example, in a machine, there can be at the max, say, 8 or 10 operators operating at the same time. But if something goes wrong with the process, hundreds or lakhs or crores of people can be affected. Okay. So this new standard, the 13849-1, is derived from IC 61508, as I have explained earlier, and is more meant for machine builders. But since it is already derived from 61508, it also has quite relevance to process industry. Okay, as far as the system implementation, design of electrical system is concerned. There's some why a new standard, because you know, older standard was quite, I mean, developed almost 10-20 years ago, and there were many advancement in the automation system, which is like safety-based electronic devices were started getting manufactured. We started having the software-based safety devices, and these aspects were not taken care into EN 954-1, and that is why we had to have 13849-1 as the new standard for control system. Okay. So what are the new aspects of this control system as far as safety is concerned? In the old system, we already had selection of safety categories. You can consider safety category as a safety level. Okay. And this was more related to how you design your circuit. Okay. But in the new standard, we have 3 more additional parameters. I again repeat, 3 more additional parameters. So the earlier parameter also remains relevant today. And we have evaluation of MTTFD. I will take upon this parameters separately in my next slides. Then the second parameter which has come as a new is evaluation of DC average. And the third parameter which is new is CCF, which is called common cause failures. And I'll just explain what they mean. So these 3 parameters have been added additionally to understand the safety levels as far as the new standards or the new scenario is concerned. And the safety category which I was talking about has been taken from EN 954-1, and they are nothing but control categories like B, 1, 2, 3, and 4. I will explain this again later on. What does these categories mean? Because the new system is also based on this. Okay. So this is the parameter, one of the parameters which we have to decide to understand what is the level of safety we have achieved or want to achieve on an automation system. And then the second parameter is mean time to dangerous failure, that is MTTFD. Okay. Now, if you go through the standards, they have given some parameters like low quality, medium quality, high quality. Just don't misunderstand this quality with the quality of the product. This is something to do with, you can say, what is the probable time for dangerous failure in that product. Okay. So this is nothing to do with the particular quality of the product. Okay. Sometimes instead of MTTFD, we are given with B10D value, which is, you can say, the second parameter is more related to hardware reliability, means how reliable your hardware is. Hardware, if I say, like say, contactor of the motor, or if I say safety switch or e-stop push button, emergency stop push button, how reliable they are as far as hardware is concerned, okay, from mechanical wear and tear point of view. So the second parameter is more about hardware reliability. And this B10D values, or you can say the mean time to dangerous failures, now onwards, I mean January 2012 onwards, all manufacturers who manufacture safety devices have to declare those values. Okay. Earlier it was not required. This parameter was not there in the safety system. Now this parameter compels all the manufacturers of safety devices to declare this value. If these values are not known, one can refer also to the standard, that is 13849-1, where some typical values are given, and these values have to be met. These values have to be met by the manufacturers. Okay. I will not go much into these details, but the third parameter is about diagnostic coverage. And diagnostic coverage is the ability of the system to detect failures in time before an accident happens. Means how intelligent your system is. Okay, this will decide whether an accident can happen or not, or whether you know that an accident will happen now. Okay, and then again some parameters are given, like no diagnostic, which is less than 60% diagnostic. So what this standard have done, they have quantified all those safety parameters. And this quantification we will just see briefly. It can be done. We can design a system and we can quantify and we can understand whether the implemented system meets our requirements or not. So there are some typical values given for diagnostic coverage also in the standards. No diagnostic, low diagnostic, medium diagnostic, and high diagnostic. And the fourth and the last parameter is common cause failure. Common cause failure is something which is related to human beings, or the way we develop a safety system. Okay, and in the standards, if you see, there are some questions given, and these questions are related to, say, design, assessment, analysis, competence, training, environments, and you have to answer those questions. These questions are like whether you have implemented the system so that there is no electromagnetic interference. If you say yes, you will get some points. If you say no, you will get 0 points. So out of all these questions, if you get 65 points, if you are able to meet 65 points, then we say we have taken care of the common cause failures. Okay, so this is the fourth parameter, and this takes care of human negligence or human error in developing a system like wiring, mounting, electromagnetic magnetic interferences, environmental, all those things. Okay. So how do we start implementing a system? The first step is risk assessment. Okay. Unless until we have a risk assessment done, we cannot understand what is the safety requirement. When I I have been to many industries, and I see people don't do risk assessment, and they just want to implement safety. This is possible that we can implement safety, but then the implemented safety may not be to the optimum level. Either we may reach over the requirement, or we may be below the requirement. So there's a very beautiful standard, again a new standard, which is EN ISO 12100-1, and this talks about general principles for design, risk assessment, and risk reduction. Okay, so you may refer to this standard for risk assessment, and these are the steps given in that standard, which I have shown on the screens now. It talks about more about machine, but then it is relevant to others also, like determination of the limits of the machinery, hazard identification, also risk estimation, then risk evaluation, and then the iterative method, whether the risk has been reduced up to the level you want or not. So just going into the briefly to explain you. See, a machine, let us suppose we take a machine for risk assessment. A machine can be made for, say, for a packaging machine. If I take, it can be made for, say, to run 2,500 RPMs. But it has been sold to a company which runs it only at 1,000 RPM because of product constraints or something. So the user doesn't know that this machine can run at 2,500 RPM. Okay, and there may be an instance after 10 years, after 15 years of that machine, that the machine may run because of some problems in the wiring or because of certain requirements at 2,500 RPM, and the operator may not be prepared for that high speed, which may lead to accidents. What I am trying to explain is that we have to understand what are the limits of the machinery. If we know what is the maximum limit of the machine, like suppose I have seen a machine where there was something which you can say a pipe cutting machine, or you can say a cylindrical pipe cutting machine, and the pipe diameter varied from, say, 40 mm or say up to 400 mm. Okay. Now, when you insert a 400 mm pipe for cutting, the clamps which used to clamp the pipe, they used to raise like anything. So if someone doesn't understand that these clamps can be raised up to that level, then there is a chance of meeting with an accident. So we have to understand what are the limits of the machinery to do a risk assessment. And then the next step is hazard identification. Hazards are always there on a machine, and there can be 100 of hazards. Okay, but all the hazards may not be risks to the human being. Okay, a hazard becomes a risk only when human being is exposed to that hazard. And this is where many people make mistakes. They want to do away with all the hazards of the machine, and this is practically not possible to do away with all the hazards. That machine will not be operable, or you will not be able to interact with the machine. So we have to find out from all those hazards which are risks. Okay, so some hazards are risks, and we have to evaluate the risk, how risky it is. Okay, the evaluation part I will take in the next slide, which you can see now. So this is the risk assessment chart, you can say. There are 3 parameters on which the risks are carried out, and this is called severity of injury. The first risk is severity of injury. The second is frequency or exposure time to the hazard. Okay, and the third is possibility of avoiding the hazard. Okay, so if you see severity of injury, it can be a slight injury, which we call as reversible injury, and second, we can say it can be very serious injury, which can include death, and frequency or exposure time to hazard. If we are frequently exposed to the hazard, then the risks are very high. But if we are not exposed to the hazard, the risks are low. Similarly, if there is a hazard and we are able to avoid that hazard by, say, means of putting a barrier or fencing or a safety device, then the risks are low. But then sometimes, suppose for a case, a person is trapped inside a robotic fence, okay, and the robot starts on its own. It's scarcely possible that he can escape, depending on the size of the fence and the way the robot moves. So such kind of things are not possible. So then the risks are very, very high. So these 3 parameters, if we analyze in the chart on the right hand side top, the blue chart, if you can see, if you say for an example, I take the severity of injury is high, that is, it is irreversible. So let us take irreversible injury as S2, and suppose we take that it is possible to avoid the hazard. So let us take F1, and let us say that it is also possible to avoid the hazard. Okay, so let us take P1. So we have S2, F1 and P1, and this reaches to performance level C. So overall you can say this is the safety level. This is the safety level of the system required, or this is the you can say the level of safety we have to implement on that machine. Okay, because if you see, to tell you very frankly, to tell you very clearly, if you see, if the hazard, if the risk or the severity of injury is high, that means S2, we can minimum reach performance level C. And if the severity of injury is S1, which is slight, we can maximum reach performance level C. Okay, so that means performance level A is the lowest risk system, and performance level E is the highest risk system. There's high risk involved. Okay, so this is how a risk assessment is done in the market, or even if you search on a Google, you will find many Excel-based charts, the Microsoft Excel-based charts available, which gives you this parameter in a different format, and you can enter all your data after hazard identification, and it will automatically calculate what is the performance level. Okay, there are also some softwares available which has to be bought definitely, which can calculate risk assessment for you after you feed in the data. But a good risk assessor, any of those chart, the philosophy remains same what I have shown here. Okay. Now we will understand what is the meaning of control categories. The first parameter of you can say understanding the safety level, and this and this one starting with the first parameter, which is control category B. Which is control category B. You can say this particular level is only related to selection of components. Okay. On the lower hand side, if you see that chart, MTTFD, mean time to dangerous failure, is low to medium. There is no diagnostic coverage of the system, and the measures for common cause failures have not been taken care of. Okay, and this control category means, if you see the system behavior, means if you see the system behavior, it means the occurrence of a fault in that safety system, it can lead to loss of safety function, means it can lead to an accident. Okay, so the control category B also important. It is also important that you see on the right top corner the control system design, which is input, logic, and output. So because later on in the slide you will find this a bit changing. Okay, so control category B. Now let us come to control category 1. Control category 1 means the requirements of B has been fulfilled. Okay, the selection of components have been taken care of, but then you have chosen a proven component, and you have also applied some safety principles. We will be talking about this, but to tell you very briefly, proven components means a component which is made for such application. Proven component doesn't mean that you have to buy a component and test it for 10 years and then you can say that, okay, this is the proven component. Proven component means the product which is designed for certain application. Okay, and safety principles applied. So if you take care of these three parameters like requirements of B, proven components, and safety principles, then we can say that we have reached control category 1. On the top right corner, the control system still looks like input, logic, output, and on the system behavior front, you can see the occurrence of a fault can lead to the loss of safety function, but the probability of a fault occurrence is lower than in B because we have applied safety principles and we have used proven components. And on the lower front, you can see MTFD, DC coverage, and CCF are not relevant. Okay. Now coming to control category 2, it is same as control category 1, but we have test input. On the right top corner, you can see on the logic, we have a test input going. That means every cycle we are testing this function. And if we are able to develop a mechanism like this, then it is more intelligent. Here you can see on the bottom hand side in the chart, on the same screen, screen number 24, diagnostic coverage has become relevant. If you go to the previous slide, diagnostic coverage was not relevant. Now the diagnostic coverage is there because you have a test input, and this test input can tell you whether there is a failure in the system. Okay, but the failure in the system can be identified only after the test. If something happens before the test, between these two test intervals, then we can meet with an accident or the safety function can be devoid. Okay. Now coming to control category 3. Control category 3, if you see on the top right corner, now we have two parallel lines of input, logic, output. So in the same system, we have two inputs, two logics, and two outputs. Okay, let us understand this. Let us take a very common device like an emergency stop device. So the push button contacts or the push button itself acts as an input, and then the logic part which takes the signal from the push button, it can be a PLC, it can be a safety relay, it can be a microprocessor based logic controllers. This is called logic part, and the output is nothing but the motor controlling devices like contactors, or you can say drives of the motors, or MPCBs or MCCBs. These are you can consider as output. So in control category 3, we have dual channel system. So 2 inputs. It doesn't mean that we have to have 2 emergency stops. It means inside the emergency stop we can have dual channel. This we will discuss later on, but just try to understand how the system behaves. If an individual fault occurs, the safety function is always maintained, and some but not all faults are detected in time. And whenever there is an accumulation of undetected faults, means more than one fault occurring at the same time, then it can lead to loss of safety function, or it can lead to accident. And here you can see the diagnostic coverage has become low to medium, and the hardware reliability has become low to high, and now we have taken care of common cause failures. So only when we have such parameters defined, we can have a control category 3 system, and we can achieve a performance level, the safety level of E maximum. Okay? And let us see what is control category 4. Control category 4, there's no difference between control category 3 and 4 as far as the logic diagram is concerned. The only difference is in the hardware being used and how they are used, which is which shows in diagnostic coverage, because these 2 parameters have become high now. MTTFD is high and diagnostic coverage is high. And here in this kind of a system, if any fault occurs, the safety function is always maintained. Now this logic diagram I have taken from 13849-1. As I have shown, this is more relevant to machines. In case of a process, there can be 3, 4, 5, 6 levels of dependencies depending on the risks involved. Okay, but this is for our understanding that we have to have a redundant system or a dual channel system. Like suppose if I take input I1, if there is any problem with input I1, logic will not get a signal, and the output device will not shut down the motor to avoid an accident. But then at the same time, I2 will be healthy, and I2 will give a signal to logic, and in turn output O2 will stop the motor and avoid the accident. So this is called the redundant system. So if there is any failure in one of the logic paths, the other path is there to take care of safety or to avoid the accidents. Because if you see on logic L1 and L2, they are talking to each other. There is a 2-sided arrow which I have shown. This means that there is a cross monitoring. So if there is any failure in I1, L1, O1 path, the I2, L2, O2 knows that there is a failure and it takes care of safety. Okay, so these are the 4 levels, you can say 5 levels of safety: B, 1, 2, 3, 4, the control categories, and the performance levels A, B, C, D, E. And the parameters are control categories, MTTFD, diagnostic coverage, and common cause failure. Okay. So if you see, I have just tried to make an analogy between performance level and SIL. Many of you will be more comfortable with SIL, which is nothing but safety integrity level, And safety integrity level is more relevant to process. But whatever I'm talking today, they are interrelated. You can see how if we have a performance level B or C, it is equivalent to safety integrity level 1. If we have a performance level D, it is equivalent to safety integrity level or SIL 2. If we have a performance level E, as per the machine standards, it is equivalent to safety integrity level 3 as per the IEC 61508, which is process as well as machines. In SIL, we also have the SIL 4, which is purely for process industry, which I will not discuss much here. But we should understand only one thing, that there are some levels of safety, and we have to understand what level of safety is there in a system so that we can implement a correct solution or an optimum solution. Okay. These are some of the typical safety functions on a machine which has been given in the standard. I will not go into into much of the details. There can be many more safety functions, and we have to take care of each and every safety function on a machine, in a process, so that we take care of safety on that particular machine or system. Okay. Now I will discuss about safe practices, the basics, and the first device which came to my mind, which is being used by everyone. I wanted to make it more, widespread. So, emergency stop devices. Emergency stop is a device which is used in each and every industry, for each and every process, for each and every machine. And many of us, we do not know what are the requirements of emergency stop. First of all, we have to have the emergency stop adhering to standards, and the standard for emergency stop is 13850. Okay. And many times we also use, emergency stop or end stop devices, which are like limit switches. Also a pull wire switch for conveyors. Also a belt alignment switch for the conveyors. And also sometimes foot switches. Foot switches are also sometimes used for emergency stop. It has some foot switches have got 3 positions: off, on, and then emergency stop. Okay. But many times I have seen in industries, inductive proximity switches are used as end stop or a safety device. Also, a magnetic switch is being used. A normal reed switch, reed type magnetic switch, are used for safety applications. So what is the difference between them? All the safety devices, especially the electromechanical safety devices, with including emergency stop devices, should have this mark, arrow in a circle. If we have such a mark on an electromechanical device, it is suitable for safety applications. I will discuss why. But inductive proximity switches, reed switches, are not suitable for safety applications. They are not proven components. You recall the slide, control category 1. Proven components and safety principles must be applied. So there are some devices which are not proven components. They are not meant for that application. Okay, so we should avoid using those devices. Okay. Now let us understand what is the meaning of this symbol. This symbol means that the contacts inside this electromechanical device is positive break type. When I say positive break, it means the NC contacts which are used for stopping the machine will positively break if you apply force on it. Like say, suppose we take for an example emergency stop. Emergency stop push buttons are operated by, making an impact on the push button head. So this impact is either by a hand or by a hammer or by anything, whatever is in your hand, because it's an emergency situation. And when you make an impact, you apply a force. This force is actually opening the NC contacts. There are no springs attached for opening of this NC contact. So that means if you have applied the force, the NC contacts will become ANO, or it will break open, and since it will break open, it will also give us command to stop the machine. Okay, so this is called positive break contacts, and this is also given in IEC, the standard I am talking about, IEC 60947-5 in Annex K. It is given there that emergency stop devices or devices used for safety applications should have a direct opening contact, which means that if you apply a force, like for an example, say we take a limit switch, which is commonly used for door guard application for safety. If you apply force on the actuator of the limit switch, okay, the lever, actuator lever operates, and this force applied on the actuator lever directly opens the NC contacts, and this is called positive break. So just keep in mind, whenever next time you implement safety, and if you use any of those electromechanical devices, ensure this arrow in a circle mark. Ensure this arrow in a circle mark. It will guarantee you that this is a fail-safe product. Okay, I will take an example here. If suppose the contacts are welded, the NC contacts are welded or are stuck because of any reason. Now if you apply a force, the force will be sufficient enough to break open those welding contacts. If that force you apply is not enough, it will destroy itself, the switch will destroy itself and still open the contacts. That is why it says positive break. Positively it will break. Okay, coming to the next safe practice. It is more related to limit switches, may not be relevant for many of you, but nevertheless, it should be mounted in a positive mode way. That means when the machine is running, when the safety guard is closed, the actuator should not be operated. The actuator of the limit switch should not be operated. The actuator, many times we have seen when the guard is closed, when the machine is running, the limit switch is mounted in a manner that the actuator is operated. Okay, but it should not be like that. The actuator should get operated only when the safety guard is opened. If you do this, then you ensure that you apply a force on the actuator of the limit switch to shut down the machine. Okay. Similarly, we should have a positive linkage when we have a limit switch for safety application. And this positive linkage, you can see in the diagram, there should be a pin, or the shaft where the lever is mounted should be square, or it should be serrated. Otherwise, the lever may slip and the contacts may not break. So any limit switch which doesn't have any of these three requirements, it is not suitable for safety applications. Okay. Now I will also talk about these two modes which are most neglected modes which I have observed of a machine, of a process, which is called setup mode and maintenance mode. in both the modes, we have to have some kind of a safety, but still run the machine and interact with the machine. Means we are exposed to the machine, but still we should have some kind of a safety. But generally in the industry, if you see during setup mode, during maintenance mode, there is no safety. Everything is bypassed. And as I discussed earlier, most of the accidents happen during these two modes nowadays. Earlier it was not so, but nowadays it happens more because in auto mode there is no interaction. Everything is automated. Material feed in, metal, the finished metal out, the process, everything is automated. Okay. So let us see what are the devices which we can use for this setup mode. And the first device which comes to my mind is the enabling handheld switch. I have seen very few machines in my last 5 to 10 years of career which have got a handheld engine device or a setup device installed on the machine. And most of our people, they operate the machine without this device. We can use any other device also, but it has to be something, some minimal safety when we do setup or maintenance. Okay. Now, if you see this particular device, the left-hand side, the big one, this device, you see a yellow color, you can say the plastic part on the switch. This yellow part is your palm operated switch. When you hold this device in your hand, your palm will come in contact with this yellow part. And this yellow part has got 3 positions. Okay, and the 3 positions are the first position, which is off, definitely. When you press it slightly, it is on, and if you press it further, then it goes to emergency stop. So, and also on the top, you can see a small push button. On the top, you can see a small push button, which is nothing but the jog push button or inch push button. So the sequence is you have to slightly press this yellow part, and then the machine is enabled for jogging. So you have to slightly press the yellow part, and then you have to put the switch for jogging. Now say this is to be held in one hand, and with the second hand you have to do the setup. If you do this this way of setup, if suppose there is some unwanted incident which is happening or going to happen, there are 2 ways you will react to that incident or event. The one way is you will throw away this device and run away. Moment you throw away, the yellow part will come to the off condition, and the jog push button will also be off, so the machine will not run. Second reaction, human being reaction, is you will hold it very tightly. You know, because this is a human psychology. Either we leave the things or we hold it very tight when there is any untoward incidents happening in our lives. Even during driving, you would have seen if something is happening, probably we put more pressure on the accelerator than putting on the brake. Sometimes it happens. So under both the conditions, you will get the machine stopped. Okay. This type of device shall also be used. So this means the emergency stop is still into service, and the emergency stop push button is in the hands of the operator who is doing the setup or who is doing the maintenance. So we have certain minimum maintenance safety available when we do the maintenance or setup. Also, we can under this condition we can also run the machine at lower speeds if possible during setup and maintenance mode. There should be a selector switch with a key operated selector switch, which should allow us to select the setup or maintenance or inching or jogging mode, and as soon as we select the jogging mode, the machine should run only at maybe half the speed or 30% or 25% of the normal speed, so that we can reduce the risks associated with the moving parts of the machine or the process. Okay, this typical circuit, which I will not discuss, but it is for your understanding, that from this switch we are monitoring two contacts. You remember dual channel, so we are monitoring two contacts, and so that we achieve higher level of safety. Okay, this is what is more relevant here. The second device, which is quite widely used in industry, is an optoelectronic safety device, which is also called as safety light curtain. And most of the places I have seen that we don't take care of the primary requirement, that is the safety distance calculation. The safety light curtains shall be mounted at an adequate distance from the hazards of the machine or the process. And for that, we need to calculate the safety distance between the safety device, which is safety light curtain, and the moving part of the machinery. If we don't do this, then before the system reacts because of this safety light curtain, our hands can go in the hazardous motion and can meet with an accident. So there is a formula for calculating safety distance. Okay, and this safety distance is calculated in millimeters, and you can see the formula is different for different resolution of light curtains. Means whether the approach is of a hand or a human body, the formula is different, but it is 2000 into T. T is the time, entire reaction time of the system, means the time taken by the system to stop, plus 8 into D minus 14, okay, which is nothing. If you can see on the lower hand side, we have also given another formula which is plus 850. Okay, this formula is available with most of the you can say the manufacturers of safety devices, but I have seen nobody calculates this safety distance, and they mount the safety light curtains at a distance which is not appropriate. So we should take care that they are mounted in correct safety distance. Okay. Another aspect of a safety device is auto manual reset. Whenever we have a safety system, suppose the sequence of operation can be that suppose the machine is running. You open one of the door guards, or you operate an emergency stop. Then the next sequence is that you rectify the problem because of which you operated the door guard or the e-stop was operated. And after the rectification of the problem, you reset the operation, and then only you should switch on the process. Okay, many times it may not be possible, but then this should be one of the requirements from risk assessment, which should come from risk assessment, whether a reset is required or not. But most of the processes, most of the machines, reset is required, and it might happen that this reset push button is faulty. If the reset push button is faulty, so it may start the process automatically moment you rectify the problem. Suppose you operate a e-stop push button, and this e-stop push button, after that you have to operate the reset push button. But since the reset push button is faulty, moment you release the e-stop push button, the machine is ready to start. Okay, and due to another fault, the machine can start automatically, which can be further dangerous. So to avoid a reset push button failure, there is a phenomena called trailing edge or edge detection push buttons. or feature in the reset circuit. This is more of a feature of a safety relay actually, or the control logic part. So what it does, when you press the push button, that time it will not reset. When you are pressing the push button, the reset push button, that time it will not reset. It will reset only when you are releasing. So it ensures that if the contacts of the reset push buttons are welded, then you will not get a reset function. Okay, so this is called trailing edge. Only when you release the push button, then only the reset function is activated. Okay, so this ensures further safety into the system. And if you go through the standards, manual reset is mandatory when we have a chance that a person can be trapped inside. Suppose we have a hazardous area, or we have a hazardous machine where a person can go inside for maintenance, and if that person is not visible from outside, then it is mandatory that there should be a manual reset. Okay, this also you can go through further into the standards. They have given beautiful examples also. Another device which is not properly used in the industry is a two-hand control device. These two-hand control devices are used mainly for press applications, but they are very commonly used for setup or maintenance operations also. Okay, and the two-hand control device, the basic requirement you can see in the red is the two push buttons shall give output only when they are pressed within 500 milliseconds. This is a requirement of the standard called EN 574. If they are pressed only within 500 milliseconds, then only we should get an output. Otherwise, the output we should not be able to get. Okay. So this is achieved by a safety relay. So we have a device which has got two push buttons. You can see push button A with one NO plus one NC contact, push button B with one NO and one NC contact, and these two push buttons are fed as an input to the safety relay. This is the control logic part, and this ensures that these two push buttons are pressed within 500 milliseconds. Then only you will get an output here on terminal number 13 and 14 to start the motor. Normally, this safety relay is not used. Neither we have this 500 millisecond gap. So this should be taken care because this is specified in the standards, and this is mandatory. Okay. Then coming to the safety relay module. Safety relay is an integral, very, very important part of a control system. You remember, again recall from our earlier discussions, we have 4 parameters required for a good safety system. The first one is control categories, which is nothing but input, logic, output. Second parameter is hardware reliability. Third parameter was diagnostic coverage, and fourth parameter was common cause failure. So safety relay module takes care of the first parameter, that is control category. So most of the safety relay available in the market are falling into control category 3 or 4. And the most important role safety relay plays in a control system, in automation control system, automated control system for safety is the diagnostic coverage. So a safety relay builds intelligence into the system. So suppose you use an emergency stop device in a system without a safety relay and directly wired to, say, contactor of the motor or, say, drive of the motor. In case there is a failure in the emergency stop push button itself, in the output contacts of the emergency stop push button, then there is no way the accident can be avoided, or the system will not know, or the operator will not know that there is a problem in the system. But if you use a safety relay, so because emergency stop push buttons are electromechanical devices, they don't have intelligence. They cannot talk to you. But safety relay modules, when we use, they build intelligence into the system. They monitor the system continuously. This is what I'm talking about. A safety relay does guard monitoring. It does detect open circuit in interconnection wiring. It detects short circuit in interconnection wiring. It detects short to ground in interconnection wiring. The interconnection wiring is for the safety control system. It also detects the welded contacts in the contactor or drive which starts the motor. Okay, so we have a input which is coming from the contactor part also, output device also. We will see this when we do something on the safety circuit design. Then it also checks failure of safety controllers positive. So it has got internal diagnostic also. So when the relay itself fails, then also it tells that I have failed, and it puts the system into a fail-safe mode. Okay. So these are the parameters which a safety relay takes care. So if you have to make your system fail-safe, if you have to make your safety system intelligent, you should use a safety relay in your safety system. A safety relay in the system makes a safety system more reliable and fail-safe. Okay. These are some of the you can say features of a safety relay, any safety relay. I'll not go much into details, but I can tell you one thing, that a safety relay has got control reliability, which is nothing but self-monitoring as well as redundancy. So the safety relay itself has got redundancy. How? We will see. This is the safety relay circuit, you can say. On the top part, okay, I will show you the inputs, outputs logic differently, but it has got self-checking capacity. It has got self-checking capacity. Then it has got dual channel inputs, means there is a redundancy in the system. And then it also has got positive guided dual channel contacts. And these three things put together make a safety relay control reliable, means the control system is more reliable. We will again see, I'll just skip to safety circuits because I'll be able to explain more about the safety relay capabilities. Again, the same diagram of a safety relay, and we can see this is the input. This input can be from emergency stop device, from door guard device, from two-hand control stations, from the enabling switch, anything which is related to safety or the safety device what we are using, even the safety light curtains. Okay, this is the input. Then we have got the control part, which is the safety relay itself, because it's a microprocessor, microcontroller based device. You can see this is the control part. We have the output part, which is nothing but the drive or the contactor of the motor. Okay, for the thing. Then we also have feedback from the contactor of the motor. This feedback ensures that if the contactor of the motor or the drive of the motor has failed, the system would not restart. And then it also ensures there is a reset in the system. And this reset can be manual or automatic, depending on the requirement of the risk assessment. So this is the basic, you can say, parameters as far as safety circuit is concerned. Means we should have a dual channel input, we should have a dual channel control, we should have a dual channel output, we should have a feedback from motor control device, and we should have a reset functionality. If we have these 5 parameters in a safety circuit, our safety circuit can be called as fail-safe. Okay, let's see how to series wire emergency stop push button or electromechanical safety device or any other safety device. Because of dual channel requirements for category 3 and category 4, you should use 2 NC contacts. If I have shown on the door guard 1, door guard 2, I have shown 2 NC contacts, and they can be series wired. Even you can include an emergency stop push button which can have 2 NC contacts, and they can be series wired to a single safety relay. Okay, this is one of the methods of connecting safety devices to achieve performance level D or control category 3. Okay, just going back, on the input side we can have the safety devices, and there if we wire many devices in series, the diagnostic coverage of the system decreases. But if we wire only one device, then the diagnostic coverage is high. So if we wire many devices in series, because of the low diagnostic coverage, the system can meet only performance level D or control category 3. The diagnostic coverage is still medium. But if we use a single device on a single safety relay, then we can achieve performance level 4 or control category, performance level E, or control category 4. But nowadays there are many intelligent safety devices available in the market which can be put in series with a single safety relay, and you can achieve performance level E or control category 4. Okay, but for all electromechanical devices, you cannot achieve performance level E if you have wired them in series. Okay, so some of the requirements of safety circuit is correct selection of the safety relay, what is the voltage of operation, what is the type of input device, whether it is an emergency stop, a door guard switch, a safety light curtain, how many number of safety output contacts you need, how many number of signaling output contacts you need, whether you need a manual or an automatic reset or reset with a trailing edge. So these are the few requirements which you should take care in selection of the safety relay. And then in selection of safety devices, we should take care of what kind of door guards are there, whether it is a dusty, water or moisture area, or what kind of usage it has got, whether we can use a metal or a plastic versions. Some of the requirements for selection of the devices used for safety in a machine or a process. This completes my session on this. Very quickly, I will take through the case study. And this case study is about a matchbox company. Okay, I will go a bit slowly because there are a lot of words in this case study, you can see. I'll just read slowly so that you can follow me. A company XYZ is into matchbox manufacturing. Okay, it has been a leader in this segment since past many years, and it has manufacturing at 5 to 6 locations all over India and is a true Indian multinational. This company has all safety systems in place, and they conduct internal as well as external audit time to time to ensure that the system is maintained. They have mostly imported machines. Please note this. They have mostly imported machines from US or Europe. And again note, only recently, approximately since past 8 to 10 years, they have started purchasing local machines to reduce the overall cost. So earlier, they were using machines all from Europe or US, but very recently, they have started developing machines locally through their vendors, definitely to reduce the overall cost. With technological advancement in Indian machine manufacturing segment, the Indian machine manufacturing segment has seen a lot of development in past 10 years. Now we have world-class machines available in India also, with all automation system, with all those kind of speeds and other things. Machines similar to those manufactured in US and Europe are available here, but almost at half the cost. Okay, and there's one very important thing which I also mentioned in the during the beginning of my slides. The company has a track record of 0 major accident in past 32 years. So company has never met with an major accident in past 32 years. Two things we have to note here. One is they have a very good safety system. Second is earlier they were using imported machines from Europe and US. Why I'm saying so? Because Europe and US, the safety standards are at a higher level from implementation point of view. Okay, and the third point to observe here is last 10 years they are using machines from local manufacturers. Okay. In their Chennai plant, in packing area, they have a machine for cutting paper rolls or papers to suitable sizes for packing, wrapping matchboxes. You know, when you go to the market, you get matchboxes wrapped in packets of 10 or 15, I don't remember exactly what is the quantity, but 10 safety matchboxes are wrapped in one paper. So they have a machine which cuts this paper into adequate size so that they can wrap those quantities of matchboxes. There are 6 such lines, okay, in that plant, in Chennai plant. And on line number 6, which is a comparatively new line is to be noted. That means the machine is new, but the machine is from a reputed local manufacturer. Okay, this is a completely automated machine and it works in 2 shifts. The only interaction or exposure of the operator to this machine in running condition is during setup mode, when the paper rolls are changed when they finish, and when there are paper jams. You know, papers are there, so there are sometimes jams developed in the machine. Okay, so these are the only incidences where the operator interacts with the machine. So it is a paper cutting machine where the paper is rolled into the machine. There is some cutter inside, okay, and this cuts into adequate sizes to wrap the matchboxes. Okay. The machine has all necessary safety guards and interlocks installed, and control is through a PLC, a normal PLC, and a drive system. All safety equipments are from reputed make and are manufactured in Europe or US. We also have an emergency stop push button in the machine. Please note that the machine has been tailor-made to suit the requirement of the company XYZ. Okay. The company officials, the XYZ company officials, have in fact asked the machine manufacturer to copy one of the imported machines from Europe. So earlier they were using an imported machine for the same process, and they asked the local manufacturer to copy that machine, which is very, very popular nowadays, and it is very cost effective. But they have maintained the same speed or the production cycle. Okay, so this is a brief description of the company, of the machine, and what kind of system is installed on the machine. What happens, we'll talk about the incident now. Now, it's very important to understand how an incident occurs, which can lead to an accident if not taken care well in time. So one of those days at 10 a.m. in the morning, in the first shift, the operator opened the transparent guard on the twin rotating cylinders. You can see there are twin rotating cylinders which feed the paper into the cutting area. Okay, you can see on these pictures I have shown some cylinders. They are not exactly from the same machine, but I have tried to show you what kind of cylinders it could be. And twin rotating cylinders where paper passes through to clear a jam. There was a jam, and at 10 a.m. the operator opened the guard, the safety guard. What happened? The machine did not stop on opening the guard. So he opened the guard and the machine did not stop. He again closed the guard and again opened it for the second time. Now the machine is stopped. You see, there was a non-reliable behavior by this guard opening and the machine is stopping. So anyway, operator cleared the jam, closed the guard and started the machine again. Okay, but somehow he observed there was a abnormal behavior, that machine guard was opened and machine didn't stop. So he reported this incident to the maintenance guys. There was no accident. Okay, so the maintenance guys came and checked everything, but nothing abnormal was found. A similar incident happened again just before lunch break, and opening of the safety guard did not stop the machine. So now the operator had to apply emergency stop to stop the machine, and after that he went for lunch. On return, he cleared the jam and restarted the machine and again reported the event to the maintenance people. So this is the second incident happening the same day, but after a few hours, that the machine guard was opened, but the machine didn't stop. Okay, so he had to apply emergency stop, and this event was also reported to the maintenance people. The maintenance people came, took a shutdown for 30 minutes during tea break, and checked opening and closing of guard with machine stopping for at least 12 to 15 times, and found everything to be okay. Okay. Now, the maintenance people also checked door safety sensors and the PLC separately for their function and found them to be working satisfactorily in that tea break time after lunch, after the second incident. At 4:45 p.m. in the evening, just before the shift closed, there was another paper jam in the same machine. Okay, another paper jam in the same machine just before the shift close time, which closes at 5 o'clock, and there was a jam at 4:45 p.m. The operator opened the guard, and again the machine did not stop. He was in a hurry because the shift closes at 5 p.m. He also had some production pressure because 2 times there was a problem in the machine. There was already a shutdown for 30 to 45 minutes. So he had a production pressure. So he took the courage to clear the jam in running condition of the machine. He did not stop the machine. His 3 fingers of right hands were crushed between the rotating rollers. Fortunately, the cutting portion was not so easily accessible. It was only the rollers where his fingers came into, because he was clearing the jam. So you can see how an accident happens. There are various incidences which can lead to accident. Okay, and as I have discussed in the in the first half of the presentation, accidents happen once in lifetime. So you see, what are the conditions under which the accident happened? 2 times the machine didn't stop. 3rd time it didn't stop just before the shift close time. If it would have been some other time, maybe it would have, the accident would have been avoided. Maybe the operator would have applied emergency stop again. But since it was shift close time, since he had production pressure, he didn't, bother. And this is human negligence, which can happen any time. This nobody has control. The control what we can have is to make the system more fail-safe. Okay. So anyway, this was the existing safety control system, which I have shown on the lower portion of the slide. You can see there were 2-3 guards on the machine, and at least 2 emergency stops. Both were connected to the PLC, and the PLC was connected to the drive, and the drive was connected to the motor. Very simple logic. Everyone knows this is how it has to be connected. Okay. Now see what was the problem. Now we will analyze what is the problem, what was the problem in connection of this. When I say the door safety sensors, these were of safety type. When I say emergency stop, these were of the safety type. PLC was not of a safety type, it was a normal PLC. Drive was also a normal drive, and motor everyone knows. So analysis part, the PLC was checked rigorously later on, and was found that one of the output relay, which was connected to the safety door sensors or the input, was operating intermittently. Intermittently means it malfunctioned, say after about 25 to 30 operations, or say after maybe 15 operations, which was not known after how many operations it will malfunction. But even this was not so sure. The product was, the PLC was sent to the manufacturer's factory, which is again a very, very reputed manufacturer. Okay, it is a very, very reputed multinational manufacturer of that PLC. And they declared that this product is working very fine. And to tell you the truth, later on, this PLC was used in same factory, but for a non-safety usage without any failure. Why I am saying this, that PLC, there was a problem, there was some problem, there was some sluggishness in the output relay, but this was not regular. This was intermittent, and you never know when it will operate sluggishly. Okay, the safety sensors were also tested on other machines and separately in the test circuit also for 2-3 days, and they worked very fine. There was no abnormal behavior observed. Then they also tested the drive system, but the drive was working very fine because it always stopped when it got a signal to stop the machine. And at that point of time when accident took place, it didn't get a signal to stop. Okay. So the conclusion is the culprit here was the PLC. This was a normal PLC and not a safety PLC. In plain words, this component was not suitable for safety applications. It was not a proven component as per control category 1. Okay. Moreover, the door safety sensors and e-stop push buttons were wired in single channel manner. If you see the existing control system, you can see the single line between these door sensors and the single line going from door sensors to PLC or e-stop to PLC. So this I have shown deliberately to tell you that this is a single channel connection method. So there was no redundancy in the system. A redundant channel to another input relay of the PLC could also have avoided the accident. Okay, so the PLC was the culprit because it was not a proven component. A normal PLC was being used for safety applications. So what should be our lesson from this case study? That the first lesson, only safety certified components shall be used for safety applications so that we can achieve hardware reliability. You can recall the requirements of a safety system. The first requirement was hardware reliability by MTTFD or BTND. The second requirement, as far as possible, depending on the risk involved, dual channel or redundant wiring system or circuit shall be done for safety control system, which is the first requirement, like the control categories, the input, logic, output part. The third lesson we learned is that we should have a feedback from motor control device, which increases the diagnostic coverage. And good safe practices shall be followed for wiring or mounting of safety devices to take care of common cause failure in the system. So a probable good safety design or circuit design would have been, which I can show you here. All the door safety sensors are still mounted in series, but with a dual channel system. You can see the two lines connected between them. You can see the two lines, dual channel system. Even the emergency stops are connected to the safety relay oblique PLC. Safety relay oblique safety PLC. Okay. And then again, this also is connected in dual channel system to the drive. So there should be two outputs going from the safety PLC to the drive. And then on the top, you can see there is a feedback which is going from drive to the safety PLC. This feedback ensures that if there is any problem in the drive, then you should get a safe condition. So a recommended safety control system would have been something like this. Okay. So this also ends my case study, and now we can have question answers. You can
Good evening, dear all. You can make the questionnaire in the tab of questions bar.
These are the questions.
Yeah. Safety automation is available with regards to hospitality industry.
We have a question. Is there a safety automation available with regards to hospitality industry? Even if you are in a hospitality industry, you will have many machines, you will have many processes, and although all those things which we have discussed will be applicable. Specifically to hospitality industry, there's nothing, I mean, which I can recall today, just now. But the principles will remain same. The principles of risk assessment, the safety strategy or the implementation strategies, all those things will remain same. Then someone has asked whether I can show the slide PL versus SIL, SIL. I'll just show this. How can I minimize this? Yeah. I'm just showing the slide PL versus SIL. You can see this slide. Okay. I'm going to see other questions. Yeah. Okay. How to increase the size? I'm not able to read. Yeah. Yeah. There's a question from Mr. Balaji Tilak, and the question says that EN 954 is a qualitative and EN 13849 is more quantitative, and make a component level approach. Confirm. Yeah, this is confirmed. EN 13849 is more quantitative. As I have said, it quantifies the achievements of a risk level and achievement or the implementation of the safety. Another question is there from Mr. Karthik Yu, and is there a recommended level? There is no thumb rule to implement safety. The recommended level is or should be as per the risk assessment. But for all practical purposes, you can see if the risk involved is more than or is irreversible injury, which you can which we have discussed, irreversible injury, it's better to go for performance level D or E. Okay, as a thumb rule, we can only say that much. As far as the CD or the presentation is concerned, in soft copy, you will have to contact CII for the same. Somebody has asked what is OTE in the control category 2. It is not in 1. Actually, it is in control category 2. This question has been asked by Mr. Modesta Kerketta. And in control category 2, this OTE is test input. Mr. Dhananjay Alsikar has asked whether for robotic application are there any specific standards defined. There is a standard, a separate standard available for robotic application for safety. Okay, and this standard I'll be just writing down for everyone to understand. Okay. Somebody has asked, can engineered redundancy be considered a safe system? Mr. Hanu Mehrotra, he has left already. But engineered redundancy, if I have understood correctly, can be a human-dependent thing which can still lead to human error or human negligence, and it can meet with an accident. So if I have understood correctly, the engineered redundancy, in my opinion, it should not be used, or we cannot depend on this. I've just written down the robotic standard. This is a specific standard for safety on robotic areas, how to use a robot, and you can refer to this standard for understanding the safety requirements. Then somebody has asked, Mr. Mukesh Kirar, he has asked what is the meaning of a safety PLC. Safety PLC is a normal PLC, but it has got all those features like a dual channel, redundancy, it has got internal diagnostic features, it has got 2 processors, it has got 2 softwares from a different batch running on 2 processors. Okay, so every input to a safety PLC is actually a dual channel input. Okay, difference wise you can say there are 2 PLCs which can make one safety PLC inside. Okay. Another question from Mr. Vijay Kumar is there any standard for mounting of pull rope switch, for example height from belt, etc.? I don't think there is a standard for this. One should mount it so that it is clearly visible to the operators, and because it is an emergency stop device, so emergency stop device should be available for use or should be visible to the operators all the time. So it should be mounted in a way that it is available and operable by all the operators all the time. Mr. Prabhakaran has asked a question, feedback from drive to PLC, what type of feedback? This feedback is whether the output contacts of the drive are stuck or not, or whenever the output contacts are enabled, the feedback should also get enabled. When the output contacts are disabled, the feedback should also get disabled. So the feedback is a true image of the output of the drive. So in case suppose the output is stuck, then the feedback will also get stuck, and this will be sensed by the safety relay or the safety PLC, and it will ensure that next start is not possible, or you should not start the machine or the process in a dangerous situation. Mr. Bala G. Tilak have asked a very good question. Could you extend your argument to oil and gas process industry, for example, offshore platform? As I have discussed in the beginning also, for oil and gas or any other process industry, the risks are many fold, and that's why the redundancy levels could be more required. Like suppose if I take for an example the Fukushima event in Japan, there were, if I'm not wrong, 6 to 7 redundant levels, because the risk involved was very high. The risk involved was so high that lakhs of people were infected. So there were 6 to 7 levels. Okay. Similarly, in an aeroplane, you have at least 2 engines. Okay, and they are powered separately. So similarly, for oil and gas process industries, we need to have more and more redundancies in the system. Okay. The standards definitely will be different. What I have discussed, 13849-1, will not be applicable for oil and gas process industry. In some extent, IC 61508 will be possible to answer your queries on this. Mr. Nitesh Jobhe has asked a question: is it necessary to use different PLC for safety and control logic? It is up to you. Nowadays, safety PLCs or the PLCs are coming with integrated safety input-output cards and integrated control logic cards, which are single channel. So in the same PLC, you can achieve safety as well as control. But otherwise, if you can always use safety PLC for normal control logic, but then it will be a costly affair. But you can always use. Another question from Vishnu Murthy Bhatt: with a PLC having EN approval, will there be inbuilt safety relay? No. A normal PLC with any kind of approval will not have a safety relay inbuilt, unless until it can take safety cards or safety inputs and outputs. As I've told you, there are now PLCs are available with both functionalities in one PLC. Reset button, Mr. Mahesh have asked a question. In a trailing edge, when we press reset button, will it go to 0 or continue? The answer is the reset button will go to 0 at the trailing edge thing. So only when then only the system can detect. Then only the system can detect that the reset function has been operated. If it doesn't go to 0, then it cannot be detected. Mr. L. Srinivas have asked which type of safety relay we could prefer, which is built through an intelligence. To tell you, sir, all safety relays available in the market have intelligence inbuilt. So any make, any product, any safety relay you can use. Just ensure that it is performance level E or at least performance level D certified. But all safety relays are supposed to inbuilt intelligence into the system, safety system. Okay, we have some more questions. I'll just read out few of them. There's a question from Mr. Chetan Sulakhe. As the safety control can be made more effectively in PLC, the price also plays a factor. Definitely price plays a very important factor, but a similar you can say effectiveness can be achieved in a safety PLC also, because both can be programmed together, I mean, in the same manner, like a ladder logic or through a software or something like that. So both the things can be, I mean, effectiveness can be maintained even if you use a safety PLC. Yeah, if you use a safety relay instead of a instead of a PLC, or you compare a safety relay with PLC, then definitely PLC is more effective as far as the controls are concerned. But then it doesn't give you that kind of safety because it is not a proven component. Mr. V. Dinesh has asked, do you have a safety standard for manufacturing fixtures? Safety standards are not for the products which are manufactured, but the process which is used for manufacturing, like what kind of machine you are using, what kind of process you are using, what devices you are using. So it will be available for those devices which are used for manufacturing fixtures, not for the fixtures. Mr. V. Dinesh has asked another question. Is it only EN standards or do we have BIS standards too? To tell you very frankly, sir, our BIS standards are not up to the mark as far as the safety is concerned. However, one thing which I wanted to mention, I forgot in the slides or in the presentation, is that we have our Indian Factory Act, which is a law, and under Factory Act it is written that all our workplace, all our industrial machines has to be safe. Now, as like any other law, the law is always vague, you know. So our law, the law of this country in India, is also vague, okay, and it is always mandatory to follow or adhere to a law than to standards. The standards are only guidelines so that we can follow law, okay. So like any other country, our country also has a very stringent law. It's another thing that it is not getting implemented in the correct manner, but nevertheless we have a very good law, although the standards are not that much up to the mark. Mr. P.K. Gupta has asked another question. Can you show the symbols used to mention the status pertaining to their safety compliance so that it is easy to understand that if the device is okay? Sir, one of the symbols which I had shown to you was the positive brake contact symbol, the arrow in the circle. Okay. Now this symbol is only pertaining to the electromechanical safety devices. But other than that, we don't have any other symbol which you can identify that, okay, this is a safety compliant device. The way we can identify a safety device which is compliant to the standards or to the requirements is by going through its data sheet. They should write, all the manufacturers, they give the information about adherence to the standards like 13849-1 or any other standard which is in the safety compliant standards. So there's no other symbol which I can tell you now. Okay. Mr. Mahesh has asked, is there any alternative if PLC fails? Alternative is you can hardwire. At least what can be done is you can have one channel going through PLC and you can have the second channel going directly to the drive. Okay. So in case the PLC fails, at least the other channel which is going directly will act upon and stop the machine or avoid the accident. Mr. Prabhakaran has asked, is there any standard format to prompt risk assessment of any machine? The chart I have shown to you, the severity of injury, frequency of exposure, and the chances to avoid the hazard. These are the basic 3 parameters on which a risk assessment has to be done. Now, you can adopt any chart or any Excel-based chart, which I have also informed you that you can search on Google. You will find many formats available in the market in the Google. So you can use any of those formats. Everything will work out to the same theme. So there is no problem. You can use any other chart, but there is no standard chart. This is the only standard 3 parameters on which the risk assessment has to be done. Somebody has asked, Mr. Acha Gurjan. He has asked, what are the possibilities of accidents during dismantling? During dismantling also, see, during the scrapping or when you are shifting the old machine from one place to other place, there can be hazards associated due to, say, lifting hooks. They may fail and the machine can fall while lifting the machine to a carrier like a lorry or a truck. Or during dismantling, there can be some hazardous motions which can develop, not completely after dismantling, but during dismantling. So all those things, all the risks involved, the risk involved during dismantling will be completely different than when it is under operation. But those risks should also be taken care of. Many of you have asked presentation sharing. I think CII will be able to help you with that. Otherwise, you can send me a request directly to my email ID. I'll just type my email ID. Okay. I have just given my email ID. You can send the request for the presentation on my email ID so that I can send you electronically. Okay. Another question people have left. Mr. Birender Verma has raised a question. You said that an arrow inside circle is a symbol for fail-safe system. Where is the position of this symbol, or is it given in the manual? Sir, this symbol is available on the electromechanical device itself. Physically, it should be printed on the device. Like suppose if you are using a limit switch, it should be printed on the limit switch itself. If you are using an emergency stop push button, this symbol should be available on the contact blocks of the emergency stop device. But this is applicable only for electromechanical device, nothing else. Mr. Abhishek Deshmukh has asked me to explain safety relay capability. Sir, safety relay builds intelligence into the system. It increases diagnostic coverage of the system. Through a safety relay, we can monitor all the field devices. Like suppose you have installed 10 emergency stop push buttons on a process, on a machine. How will you ensure that all these 10 safety emergency stop push buttons are healthy? Because emergency stop push buttons are operated maybe once in 5 years, once in 2 years, once in 6 months, don't know. But whenever they are being operated, they should get operated for, they should give the required signal for stopping the machine. So emergency stop, so safety relay ensures that all your devices are in healthy condition before you operate them. Mr. Ayer Lakshmi Narayanan, he has asked a question. You covered about, in the presentation you covered about diagnostic features. Let's say in case of Siemens PLC and input outputs, we have diagonal buffers, diagnostic buffers, so that we get information from the module where you referring similar functionality. Sir, when I say diagnostic feature, the diagnostic feature means that in case of any failure in the safety system, the system you should be, or the operator should be able to know that there is a failure in the safety system. So if in the Siemens PLC and input output, if this diagnostic buffer gives you that information, suppose you have connected an emergency stop push button to this PLC, and in case of a failure of emergency stop push button on the contact, suppose the NC contacts are welded, and through this PLC you come to know whenever they weld, then it is the same functionality. A very good question from Mr. Paranidharan. Mr. Paranidharan has asked, pressurizing equipment, how to measure safety and control. Pressurizing equipment, if you say, if I talk about a valve for pneumatic or hydraulic, so we have a safety valves available as a product for pressurizing equipments also. Now suppose, for example, you take a press machine which operates on hydraulic principle. Okay, the output is not electrical, but the output is hydraulic. So there we need to have a safety valve, okay, which is dual channel and which can take a feedback, okay, so that in case of a failure in the system, it makes the system fail safe. So even for pressurizing equipment, the same safety and control systems will apply. Only thing is the products will vary, products will change. Mr. Prabhakaran has again asked, is it possible to have some demos for safety relay, e-stop push button, safety limit switches? Please send the, I will request that please send the request on my email ID, which I have just broadcasted. So please send it on them. I will ask one of the colleagues to interact with you on this. Mr. Narayan G. Muramati, he has asked, dual check safety or safety relay, which will give more safety? In my opinion, both mean same. Dual check safety, even the safety relay, the job is dual check. If you achieve dual check safety with a device other than safety relay, there may be a problem, because safety relay has got many other functionalities like internal diagnostic checking capability, okay, which if your device doesn't have, then there may be a problem. Otherwise, both should mean the same. Mr. DM Hayes, H-A-S-E, Mr. DM Hayes, he has asked a question, expensive electronic devices due to power fluctuations, how to overcome a failure? Sir, for this I think you'll have to install a good fuse system or a power fluctuation system in your control supply also. But nowadays most of the electronic devices have quite a wide band of voltage available. So the one way is to have definitely a good backup for the system, like providing fuses or short circuit devices. And the second is to have wideband operated electronic devices. Like a safety relay, it can be operated from 48 volt to 230 volt AC. Okay, so this kind of devices. Mr. Prabhakaran has asked another question. Is type 2 light curtain requires a safety relay or not? Sir, it depends what level of safety you want to achieve. If you want to achieve PLA or B or C, then in my opinion, it may not be required. But if you want to achieve PLD or PLE, then you may require a safety relay. So everything depends on the risk assessment and what is the level of risk. Mr. Kamaljeet Singh Malhotra has asked from where we can get the details for the specification and requirement of safety PLC. A specification is something which is dependent on your usage. You have to only categorize the name as safety PLC, and there are many manufacturers, reputed manufacturers in the market who can supply you a safety PLC. The specification is that each input is a dual channel input inside. Each output is a dual channel output inside. That's the only requirement. And there's a different categorization of this product. So any manufacturer, whoever you are buying a normal PLC, you ask your manufacturer whether they can provide you with a safety PLC. Or you can search the web and you will find many other suppliers for safety PLC. There is no standard specification or requirement. Mr. BK Sahu has asked what is the standard number for robotic system. I think I have already given, I give once again. I'll just give that robotic standard number again. It is EN ISO 10218-1. You can see I hope now everyone has seen the robotic standard number. Mr. Narayan G. Muramati has asked another question. We are making new machines with C mark. Is it necessary to follow EN ISO 1200? Okay, sir, yeah. Since you are a manufacturer of the machine, you should do a risk assessment of the machine to understand what level of safety is required on the machine. If you don't do this, and to understand that, you should follow one of those standards. The second option is that you search the website whether your machine falls into type C standards, and then you can buy a copy of that type C standard for that particular machine which you are manufacturing, and you can just follow that particular standard only. then you need not follow any other standard. But if your machine doesn't fall under type C standard, then you might have to follow many other standards. Like one of them is EN ISO 12100. Okay. I'm just reading few more questions which are more relevant, and then I can share with you, all of you. Mr. Rajesh Mohanan, he has asked a question: how many layers of redundancy, 2 or more, of safety systems are generally recommended in automated systems, accidents in which can lead to irreversible injuries to personnel? So there's no thumb rule that how many redundancies you should have. This should be a requirement from risk assessment. If you do a proper risk assessment, if the injury levels are very high, then you could have, like I shared with you, Fukushima in Japan, it has got 6 to 7 levels of redundancy. Okay. So it all depends on the risk assessment. There is no recommendation on this part, or there is no standard rule or thumb rule on this. There was a question from Mr. Kailash Negi, although he is offline now, but this question is quite relevant. He's saying, is this requirements as per the Factory Act in India? Sir, and to everyone, it is what I wanted to discuss with you is the Factory Act is the law of India, and the law is never specific. Law always says that in case there is an accident in a workplace, whoever is responsible for this, some action will be taken, or the factory will be closed, or something will happen. They don't say whether you have to use emergency stop for being safe, or they never say whether you have to use an interlocking device for being safe. They always talk about safety in a broad sense. Okay, if any one of you wants more detail on Factory Act, you can be in touch with me. I can send you some more detailed literature on Factory Act requirements for different types of machines at least. Mr. Mandar Birje from Vatsila, India, he has asked, how do we ensure the software codes which are written for a particular application are reliable? Are there any specification for writing codes, or is there any classification body who checks these codes written? Sir, if I am not mistaken, you are talking about the codes which are written in the PLC or the safety PLC. The way you write the codes, software codes, if you are a manufacturer of those safety PLC, there are definitely some guidelines available. But if you are a user, there are no guidelines of programming those codes, or programming those, or configuring those PLCs. So from manufacturer point of view, yes, there are some guidelines available how to manufacture a safety PLC. And these guidelines are from, again, from European standards point of view. Yeah, Mr. Pratap Singh from DCM Textiles Hisar, he is saying sometimes PLC has been hanged in normal condition, normal running condition. What could be the possible causes? Now this is again a software error, and the possible causes could be one of the cause what we have seen in our case study, that you will not get an output and the machine may not stop when you want it to stop. And that is why PLC is not a safe device. It is not a proven component. Mr. L. Srinivas has asked, is there a possibility to get the ladder logic diagram of the PLCs which we have been used in our company? If you are talking about from safety point of view, or whether you are talking from your specific PLC which has been installed in your factory point of view, I think you'll have to contact your manufacturer of the PLC. But if you are talking about safety point of view, then even the safety PLC has got the same kind of ladder logic diagrams. And you can program a safety PLC also in the same manner as you program a normal PLC. Okay, so there is no difference. Mr. Vishnumurthy Bhatt has asked how to decide the safe operating distance for optoelectronic sensor like lid proximity. Lid proximity, sir, you'll have to, he has already left anyway. On the case study, there is a question from Mr. Ravindra Mali. He has already left, but I think this is quite relevant. The root cause of incident was the PLC. Why there was so elaboration of imported machine and then Indian make? Does it means machine manufacturers in India was not safe? This is a point which I wanted to reiterate. In India, the safety concepts are still at a very nascent stage. And whenever you buy a equipment, it may not be safe unless until you have asked for it, which is not the case in Europe or US. There the law is so stringent and the implementation of the law is so strict that no manufacturers makes a machine which is not safe. So all the machines manufactured in Europe or US are safe up to the requirement. And that is why I had made a lot of emphasis on imported machine and Indian machine. It's not that Indian manufacturers are not capable of making such kind of machines. They are very much capable, but they don't want to invest more money. And if you ask those manufacturers to give you more safety, they'll be able to give you. There's no problem. The only thing is there's lack of awareness among the users, and that is why we don't demand and the manufacturers do not give. Okay. Mr. G. Sivaprasad has asked, what is the reliability between optoelectronic devices and electromechanical devices? Optoelectronic devices are more intelligent devices because there is electronics and it can have a self-diagnostic feature. Some kind of intelligence can be built into those electronic devices, but electromechanical devices do not have intelligence if they are alone without a safety relay. Just note down this. G. Sivaprasad. We'll have to answer them because he has already left. Mr. Rama Reddy. Mr. Vilas Bhosle has asked what is the full form of IEC. I'm just sharing with all of you. PPT share. Mr. Agam Kumar has asked what level of automation should be done in the steel industry. Sir, actually speaking, I cannot comment on this because this is a very, very broad question. What level of automation? If you ask me what level of safety, it all depends on the risk involved. Your furnace shop will have a different level of safety requirement. Your coke oven shop will have a different level of safety requirement. Your packing area or wherever you store your metal will have a different level of safety requirement. It all depends on the risk assessment. So you have to carry out a risk assessment, then only we can understand what kind of safety has to be implemented. This is for Mr. Agam Kumar. Mr. Nitesh Jobhe has asked safety distances. I think we have already discussed about the safety distances. So what we can do, we can come back to you on the safety distance formula. Maybe we can send you there is a software calculator available, and this we can send it to you. Mr. Biju Dinesh has asked to explain handheld switch with circuit diagram. Probably it will not be, it will take a lot of time to explain this in detail. So you can be contact with me through my email ID, and then I can come back to you, sir. Mr. Ayal Lakshmi Narayanan has asked, do we get wire break information? If you are talking about wire break information, short circuit information, yes, you get information about wire breaks or open circuits or short circuits if you have intelligence in the system. That means if you have a safety relay or electronic device which has got that kind of intelligence. So you get these features available in the system. Mr. Paresh Dalal has asked a very relevant question. From the safety point of view, which equipment be used for interlocking of doors or flaps, limit switches or magnetic sensors? Sir, both can be used. We have to understand both can be used provided this magnetic sensor is a magnetic safety sensor. Okay, it should not be a normal magnetic switch read type. It should be a magnetic safety sensor, and the limit switches also should be of safety type with the positive break contacts, the arrow in a circle mark. Both can be used. The only difference I can see is the limit switches can be bypassed easily. So if you have a manpower oriented industry where you have a lot of people working in the area, so there are chances that limit switches can be bypassed easily. So under those conditions, you should use a magnetic safety sensor. But otherwise, both are equally acceptable. as far as a safety device is concerned. Mr. B.K. Sahu has asked, how can a pressure reading display system reliability checked? Sir, if it is only a display system, then I don't know. You can have a dual system of reading it, but I'm not very much sure about the system. But if I talk about from safety point of view, if that reading of the pressure is leading to switching on or off of some valves, if suppose there is an overpressure and then automatically some valve should close or open, then again you should have a safety valve and you should use the same dual channel system and you should use the same feedback functionality. The philosophy remains same, absolutely same. But if it is only for display system, I'm not very sure about this system. Mr. A. Ajagurjan. Mr. A. Ajagurjan has asked, even reputed company product has low redundance comment. Sir, it is not a reputed company or anything. A reputed company also makes inductive proximity switch. A reputed company also makes a limit switch which doesn't have that safety compliance mark. But they are not supposed to be used for safety applications. And if you ask those companies whether can I use this for safety application, they will say you, no, this cannot be used. But if you don't ask and if you use it, so there is a lack of awareness, and it is not the people who are manufacturing are at fault, but it is the people who are using are at fault because of lack of awareness. They don't know that a separate product line is available for safety, and they should not be mixed with a normal product. Mr. Pratap Singh has asked a question, what is the chance of failure of safety PLC? Sir, chance of failure of safety PLC is, it has got only dual redundancy. Okay, if a fault occurs or if two faults occur at the same time, okay, the chances of which is very remote in a normal condition, then it will fail. But I mean, this is possible because there is only a dual channel, and if both the channels fail at the same time, then it will fail. Just recall my example of Fukushima in Japan. It had got 6 to 7 redundancies, but it failed because nobody had assumed or presumed what would be kind of disaster happening. There were 7 stages of power. That one power failed, the second power would be given, third power will be given, fourth power will be given, but all of them failed one by one, or even at the same time. Mr. Reddy Ramakrishna has asked why proximity sensors frequently fail and giving safety problems in AFFS machines. Sir, if you have used proximity sensors for door guards application, then definitely you have not done the right thing. The proximity sensors are not a safety device. Okay, you should immediately change over to a safety limit switch or a safety magnetic sensors or safety switches. Mr. D.M. Hayes has asked to elaborate more on MTTFD. This is more of a statistical formula parameter. It only means in a layman language the mean time to dangerous failure. So what is the time required for this product to fail dangerously? And if you talk about the products available in the market, or if you see the parameters given in the standards, they say anything which is more than 100 years is okay. So it is totally a statistical parameter, but a statistical parameter is derived from a real life situation. Okay, the statistical parameter is derived so that we can quantify the levels what we are talking about, which is there in the standards. What are the, Mr. Kamaljeet Singh Malhotra has asked a question, what are the various safety legislation in India? If you talk about the legislation, it is Indian Factory Act 1946. This is the only law available in India as far as safety is concerned, where industrial safety is mentioned. And it talks both about the safety of process or machine. Mr. Modesta Kerketa, he has said, my plant is certified with SIL 2 certification. How long the certification will be valid? Sir, first of all, you should contact the person who has given you the SIL 2 certification for understanding how long it will be valid. But if you ask me, as long as you do not make any changes in the system, as long as you are able to maintain the system, I think it should be valid. But then there are some wear and tear available with the devices, and if that happens, and because of that the safety can be avoided or safety can be downgraded, then you will have a lower SIL 2 or SIL level. Mr. Pramod K. Sharma from MGTL has asked, what are the tools to audit the risk management in manufacturing industry? So there are no thumb rules, there are no written rules to audit the risk management. Each and every industry, even two similar industries, will have two different benchmarks. It all depends on the process, it depends on the people, and it depends on the location. A machine or a person behaving in a night shift will be different from a person behaving with the same machine in the day shift. So we have to understand both the shifts in different aspects. Mr. Shiva Prasad, I think you had left, but you had asked a question. Please explain about the reliability of optoelectronic devices compared to electromechanical devices. Optoelectronic devices are more reliable because they have more diagnostic feature inbuilt. They have more intelligence inbuilt, while the electromechanical devices are dumb devices. They will never tell you before an accident happens or before they fail or when they fail. So an electronic device is better than an electromechanical device. But if you use an electromechanical device with an intelligent device like a safety relay, then the output may be same. Second thing, in electromechanical devices, we have a chances of wear and tear, which we cannot detect even through a safety relay. But in case of an optoelectronic device, we don't have any mechanical wear and tear. Okay, so that way optoelectronic devices are better in terms of reliability than electromechanical devices. But then some applications, optoelectronic devices cannot work. We have only electromechanical devices which can work, because optoelectronic devices, you cannot see whether it is working or not. And that is why whenever you use optoelectronic devices, it should be safety certified or safety compliant. But electromechanical devices, you can see physically it is working. Like say, if you have an overhead crane in your industry, an overhead crane, the end stops, you should always have an electromechanical device for end stop, because you can see that the lever is being actuated and the crane is being stopped. And there you should not use an optoelectronic device. Okay, so application to application it will differ, but in totality, if you see, electronic devices are more reliable because they are intelligent. Mr. Balaji Tilak has asked a question: how machine startup safety and shutdown safety differ in ZIL level? I don't think there's any difference in that as far as ZIL level is concerned, because ZIL level is a parameter of probability of failure or dangerous failure. So it all depends on that particular parameter. It doesn't matter whether it is a ZIL or it is a PL, it doesn't matter. Mr. Paresh Dalal has asked, should the earthing circuit for VFD, UPS and electrical panel be separate? To tell you very frankly, I don't have any clue about it, but from my experience, I can tell you the earthing system should be separate for all those devices, so that they are earthed separately, so that the surges or the problems in one device should not affect the other device. Okay, but I have no further idea about this. Mr. Agam Kumar from Tata Steel has again asked a question: during risk assessment and checking the safeguard, is there any book available on it? So for risk assessment, if you're talking about a machine, I have given you the risk assessment number, the standards, EN, ISO, I'll just write down. EN ISO 1200-1. This is the risk assessment standard. Okay, but you'll have to check whether it is applicable. This risk assessment is applicable for more for machines, but similar way you can do risk assessment for process also. The steps would be almost same. The implementation part will differ. Okay. How many safety interlocks is suitable in single operation in chemical plant? Mr. Paresh Dalal has asked, how many safety interlocks is suitable in single operation in chemical plant? So this is a very question which I cannot answer, because I don't know what is the risk involved, how many people are affected, and how many levels are required, how many door guards are available. If you have to achieve PLE, which is the maximum for a machine, if you have a chemical machine, then if you have to achieve PLE, then you should at least use two electromechanical safety interlocks. Mr. Chandrasekhar Rao or Mr. K.S. Anna, they have asked, can you please suggest us good brand of safety PLC drive? Sir, on this forum, we are not discussing about the brand or a make. You can contact me later on. Maybe we can discuss on this. Mr. Sharath Giridhar has asked, is there any specific compliance or statutory norms to be maintained for the level of safety in equipments? So the level of safety is always for a system, and although it is also available for equipment, but then there is no specific statutory norms that, okay, this equipment should be available for this level of safety. It is for you or your usage which defines what level of safety you require. Like suppose if I say a limit switch which is used on a door guard, it doesn't have its own level of safety. But if you talk about the safety relay, it has its own safety level. Okay. So what is the difference between these two? The safety, the limit switch is not an intelligent device, but a safety relay is. Okay. And if you put you will never put a limit switch without a safety relay in a good practice. If you put both of them, then you have to find out the level of the whole system and not only the individual components. Mr. G. Siva Prasad has asked another question. Is there any alternative device available in case of PLC with cost effectiveness? Sir, I don't know what kind of application you have and where you want to have this alternative device, but I mean, you can achieve the same thing with a relay, with a lot of relays, but it will give you cost effectiveness, but it will decrease your productivity. It will decrease the reliability. Mr. Balaji Tilak has asked, as per your conclusion, only safety certified components shall be used. Can you tell us in which standard it is mentioned? So this is mentioned in EN ISO 13849-1, as well as you should understand that only safety certified components shall be used for safety applications, because the category 1 requirement says proven components shall be used. Okay, so it is given in EN ISO 13849-1. Mr. Tilak, you have again asked, only safety certified components shall be used. Is this applicable for process industry? Yes, it is applicable for process industry also, that you should use safety certified components because they are proven, they are made for such applications. Otherwise you can achieve same functionality with other non-safety certified components, but it will not give you that reliability. We have already come to the end of the session. It's already 5 o'clock in the evening, and I will thank all of you who have attended this session. I'm again relaying my email ID. If you have any further questions, you can be in touch with me on this email ID. I'll be very happy to come back to your queries or issues. Okay, I have just relayed my email ID. If you have any further queries, you can come back to me on this email ID. I will be very grateful to answer your queries. And once again, thank all of you for attending this session. And it was a pleasure talking to all of you.